Hi, everybody. So sorry that I'm not there today. I'm at home with a sick baby and hoping that he gets better soon. This actually worked out okay for us because today's lesson is brief and fairly simple. So you will want a formula sheet. So you might press pause and go get a formula sheet because we're going to use the formulas to find the mean and the standard deviation of a binomial random variable. All right, but first let's just talk about describing a distribution. So if we describe a probability distribution or any distribution, you might be remembering that we use SOX, shape, outliers, center, spread. Outliers are not a thing with binomial random variables because it's not data points that we're looking at. So really we just think about shape, center, and spread. All right, so if we look at this probability of distribution for X, this relates back to a problem we did yesterday. The values of X represent the number of children with type O blood in a family with 5 children. And remember, yesterday we learned the ways to finding probabilities of exact X values. And so we could have used our probability formula or binom PDF to find the probability of 0, the probability of 1, the probability of 2, 3, 4, and 5 to get that probability distribution. Lucky for us, it was given. All right. Then we have our probability histogram. Based on the histogram, I want you to be thinking about the shape, right? Obviously not a symmetric shape. In this case, it is skewed, and this shape is skewed with a tail that is on the right. So this is skewed to the right. Okay. How would we find center? Well, we could find the mean, which based on what we know for a discrete random variable would be 0 times 0.2373 plus 1 times 0.3955, etc., right? And how can we find the spread? Well, we could find standard deviation. I apologize for my clicky Apple Pencil. And remember to do that. We would find the standard deviation of X. This would have been the mean of X. The big square root of the X value 0 minus the mean squared times 0.2373 ... Continuing that pattern. All right, that's what we know about discrete random variables. Luckily for us, the mean, which is 1.25, could have been found by multiplying the number of children, n, which was 5, by the probability of success, p, which was 0.25. 5 times 0.25 is 1.25. All right, and that method can be used to find the mean of any binomial random variable when you have the n and the p values. And so this brings us to our formulas. When you have checked off bins and you know you have a binomial distribution, then you can find the mean of your binomial random variable x by multiplying n and p. And you can find the standard deviation, I'm looking at these guys right here, by taking the square root of n times p times 1 minus p. All right, now below that box is really important red text. These formulas work only for binomial distributions. They cannot be used any other time. So you can only use these formulas that appear on the formula sheet next to the binomial random variable x when you know you have a binomial distribution. So let's just prove that mean of x is n times p, 5 children, times 0.25, which was 1.25 children. And then the standard deviation is the square root of n times p times 1 minus p. Which, hang on, I'm going to plug into the calculator. Is 0.968, so 97. Okay. Example 4, Mr. Boyard's 21 AP Statistics students did the activity on page 340. This is from the textbook. Okay, this activity had them guessing with 3 cups of water which of those cups were tap water and which were bottled water. And so based on that, we know that each student has a 1/3 chance of correctly identifying the type of water by guessing. And we're going to let X, the number of students who are correctly identifying the cup containing the different type of water, find the mean and standard deviation for this binomial random variable. So because it says it's a binomial random variable, we do not need to show bins. We have no need. We already proved that. Well, I guess it was provided. So we can go right to the mean of X, which is N times P. So 21 times 1/3 would be 7 students. And the standard deviation of X, which would be the square root of N times P times 1 minus P. Which, give me a second again. It's 2.16 students. All right, the next example, 5. The makers of a Diet Cola claim that its taste is indistinguishable from the full calorie version of the same cola. To investigate, an AP Statistics student named Emily prepared small samples of each type of soda in identical cups. Then she had volunteers taste each cola in a random order and try to identify which was the Diet Cola and which was the regular cola. Overall, 23 of the 30 subjects made the correct identification. If we assume that the volunteers really couldn't tell the difference, then each one was guessing with a 1/2 chance of being correct. We're going to let X be the number of volunteers who correctly identify the colas. First, we have to explain why it's a binomial random variable. We're going to do so just by checking off bins. So this is binary because a student is either correct or incorrect. Is independent because she used a random order. There is a specified number of trials because there were 30 students. And S, the probability of success is 1/2. Now the mean of X would be the average number of students she could expect to be correct. So 30, which is N, times 1/2, which is P, is 15 students. Then the standard deviation is the square root of N times P times 1 minus P, which is 2.74 students. All right. Now we have a probability question. What is the probability that 23 of the volunteers correctly identified the colas? So we're finding the probability that X is 23, which is the result that it says they got, right? It says up here, overall 23 of the 30 subjects made the correct identification, which is kind of a lot higher number than what we would have expected, because we would have expected 15 based on the mean, which is the expected value. All right, to do this, we could use one of the 2 methods that we learned yesterday. So I will show both, just so you know both, but remember, you don't have to do them. All right, so using our formula, we have 30 choose 23 times the probability of success, 1/2 to the 23rd, times the probability of failure, 1 minus 1/2 to the 30 minus 23rd. All right, remember to get 30 choose 23, we're going to hit math, arrow over to probability, NCR, and we're going to multiply that by 1/2 to the 23rd, and multiply that by 1 minus 1/2 to the 7th, which is 0.00189, so I'll say 1 which is 0.19%. Now remember, the alternative way to do this would be using Binom PDF with an n value of 30, a p value of 1/2, and an x value of 23. It's 0.0019, obviously. All right, so I told you, very brief, hopefully very easy. There's a few probability questions mixed in there if you get stuck. Maybe you look at our notes from yesterday, so think about what would no more than 2 look like. What possible number of engines could that be, right? So see what you can do, submit it, and I'll try hard to get those graded this weekend. Remember that on Monday, we'll take one last day of notes over binomial distributions. And on Tuesday, we'll have a practice day. All right, so I'll see you then, and I hope you have a really great weekend. Thanks for working hard today.